Hello and welcome to today's tutorial on exponents and roots. Since it is a lengthy topic, therefore I have divided it into two parts. Now let us begin with the first slide. If we have a question which says what is 9 under the root equal to, it is going to yield two answers, +3 and -3. But for GRE, we will always consider n to be greater than or equal to 0. Therefore, our answer will be +3. In case of an odd root, we do not need to worry much because it will give us an answer similar to the sign of the base. For example, -8 under the root of 3 is going to give us an answer which is equal to -2. Because if a base with negative sign is multiplied by odd number of times, the sign with the base will remain negative. Now these are a few examples of how we can simplify questions based on roots. Kindly note that x under root n is equal to x to the power 1 over n, and x power m, the whole raised to power n, is equal to x raised to the power m into n. This can further be understood by the example 3 squared, the whole raised to the power 5 is equal to 3 raised to the power 2 into 5, which is equal to 3 raised to the power 10. In other words, if we have something like the nth root of x, it can be written as x raised to the power 1 over n. And x power m, the whole raised to the power n, is equal to x power m into n. This is called the power law. Now, this question is asking us to simplify 27 raised to the power 2 by 3. Over here, 27 is the base and 2 by 3 is the fractional exponent. If we apply the power law, which we have discussed in the last slide, we can easily solve this question. I want you to solve this question, and if you have any issues, kindly leave a comment under this video so that I know if you've understood this question or not. Now let us discuss the properties of power. Now xy under the root can be simplified as x under the root into y under the root, and x over y under the root can be written as x under the root divided by y under the root. Now if we have the same powers of two or more bases, like x power m into y power m, can be simplified as x into y, the whole power m, right? This is the power of product property. Now if we have x power m divided by y power m, you see the powers are the same, right? So we can also write it as x over y, the whole raised to the power m. This is power of quotient, and in both the cases the powers are the same, right? This question is related to the power of product property, which we have already discussed in the last slide. Therefore 25 into 144 under the root can be simplified further and we'll get the answer as 60. Now kindly note that it works only for multiplication and division, but not for addition or subtraction, right? Now if we have a question which says 3 power 9 into 3 raised to the power 12 is equal to what? We can easily solve the question by adding the powers, that is 3 raised to the power 9 plus 12 is going to give us 3 raised to the power 21. In case of addition, what we are going to do is that we are going to factorize. For example, if we have a question which says 7 power 5 plus 7 power 7 is equal to what? Now since since the bases are the same, we will factorize it by writing 7 power 5 outside, and in the brackets we are going to write 1 plus 7 square, which is equal to 7 power 5 into 1 plus 49, and it is going to give us an answer which is 50 into 7 raised to the power 5. Now when factoring terms with exponents, look for the highest common factor of terms and then simplify it, right? This is another question on exponents and roots. It is a very interesting and simple question because in the numerator we can see 3 terms having the same base. So what we're going to do is apply factorization, right? And we're going to get an answer which is equal to 2 raised to the power 14, 3 raised to the power 4 into 157. We can further simplify it, but it is going to give us a very long answer. What you need to know is how you're going to simplify a complicated question. This one is very simple, right? We are now going to discuss rationalization, and the logic behind rationalization is that it makes calculations and problem solving simpler. For example, 10 over under root 2 can be simplified by multiplying and dividing the expression by under root 2. Now we get the answer as 5 into 2 under the root, which is quite simple and easy, right? Now if we have another question that says 8 over 2 minus under root 2 is equal to what? What we're going to do is that we're going to multiply and divide the expression by 2 plus under root 2. Now the logic behind it is that we are applying the formula a square minus b square is equal to a plus b into a minus b. This way we are going to get rid of the under root in the denominator, right? Now this is going to give us an answer which is 8 plus 4 into 2 under the root. Easy, right? Now kindly note that when exponents equal 2 or 3, we can write it in a number of ways. And remember, on GRE you can be asked very simple questions with a tweak. So 5 square can be written as 5 to the power of 2, 5 to the second power of 5 squared, and 9 power 3 can be written as 9 to the power of 3, 9 to the third power, or 9 cubed. Like other mathematical terms, the properties of exponents are also very important for your GRE. Kindly remember that GRE tests how well versed you are with the mathematical properties and laws. Now the first property of exponents says that when the base is equal to 1, which is 1 raised to any power will always equal to 1, right? For example, 1 power 21 is equal to 1. 1 power 0 is also equal to 1, right? Now when base is equal to 0, or in other words 0 raised to any non-zero power will always equal to 0. For example, 0 power 50 is equal to 0. 0 power 1 is equal to 0, right? Now kindly note that the answer to 0 power 0 is unknown. Hence GRE will never be testing you on the value of 0 power 0, right? Now the third property of exponents says that when an exponent is equal to 0 or any non-zero number raised to the power of 0 will be equal to 1, right? And this can be proved by the expression 2 raised to the power 5 divided by 2 raised to the power 5 is equal to 2 raised to the power 5 minus 5, which is equal to 2 raised to the power 0, which is equal to 1. Now when an exponent equals 1, any number, for example a raised to the power 1 will equal to a, right? For example, 3 raised to the power 1 is equal to 3, minus 7 raised to the power 1 is equal to minus 7, so on and so forth. When there is no exponent, right? When there is no exponent, then what are we going to do? We are going to assume it to be 1. For example, 1 is equal to 1 raised to the power 1. Minus 5 is equal to minus 5 raised to the power 1, right? In other words, a is equal to a raised to the power 1. Now the last property of exponents is about even and odd exponents. A negative number raised to even power will always give us a positive outcome. For example, minus 1 raised to the power 52 is equal to 1. And a negative number raised to odd power will always result in a negative outcome. For example, minus 1 raised to the power 51 is equal to minus 1. This is what we've already discussed earlier, which is that when a negative sign in the base is multiplied by odd number of times, we will get a negative sign with the base, right? Now kindly note that an odd exponent preserves the sign of the base with a non-zero number. For example, a power 3 is equal to 8, which is a is equal to 2. And an even exponent always gives us a positive result if the base is non-zero. For example, a square is equal to 4 and a is equal to 2, or a is equal to minus 2, right? Now coming to the last slide of today's video tutorial on exponents and roots, kindly memorize the following powers of 2, 3, 4, 5 and 10. It is really going to help you out on your test day. With this, we come to the end of the first part of video tutorial on exponents and roots. I will be uploading its second part in the coming days. Exponents and roots is a very important topic of GRE. So keep watching this channel, stay positive, stay happy. Goodbye for now, and thank you very much. Best of luck to you. Bye-bye.